So today we're going to do arithmetic and geometric sequences. Arithmetic sequences is 3-6 and geometric sequences is 9-1. So an arithmetic sequence is an addition or subtraction pattern between the numbers. You've already worked with sequences. We worked with them in the form of linear functions. So I'm going to show you the connection between a linear function and a sequence. But to fill in these values here, it says a sequence where each term changes by addition or subtraction of some constant term. You know it as a constant rate of change, but when we're talking about a sequence, it's called a common difference. And it's represented by the variable d. So it's how everything is changing. In this example, I have 0.75, 1, and 1.25. So this is increasing, so you're adding a constant value or a common difference. And here it would be 0.25. And then this is your formula to figure out a sequence, more specifically an arithmetic sequence. However, don't feel like you need to memorize this because you get this formula on the Park reference sheet. So when you see the variable a just represents some term in the sequence. It could be any term. The first term, the second term, the third term, and so on. N represents a specific term number. So this is going to be a term number, meaning the 6th term, the 7th term, or the 8th term. A sub 1 is specifically the first term, and D represents that common difference again. Okay, so let's do an example here. So find the 22nd term. This is telling you what term number we're going to find. So this is going to be our n, 22nd term. And then our pattern is 5, 2, -1, -4. So it's going down, so we're going to be subtracting a value. This 5 is our first term, so that's going to be our a sub 1 term because it's the first one. And now we got to find the common difference. So from 5 to 2 is -3, and that pattern actually works all the way down. So that -3 is going to be in for our variable d. So to do the work for this one, we're going to have here, I'm going to write the formula, a sub n, but instead of n, I'm going to put 22. So a sub 22 equals, and then it's a sub 1, which is our first term of 5, and then comes plus, and then it says n minus 1, so 22 minus 1 times d, which is the common difference, and in our example, it is -3. So this is what we're going to be solving here. So let's do the parentheses first, so 22 minus 1, so we're going to have 5 plus 21 times -3. 21 times -3 is going to give us a -63. So we're going to have 5 plus -63. Or if you want to change the two signs here, a plus and a minus, make a minus. So 5 minus 63. So a sub 22 equals -58. So that's how you use the formula to find a specific term. Now you may be thinking that if it's a constant rate of change of a number, if it's going to be -3, -3, -3, well then that's a linear function. And you're absolutely right. So if you forget how to do this, or you don't have the formula, or for whatever reason you don't want to do the formula, you could always make a linear function. So let's make a table. We're going to do the exact same problem. Okay, remember our pattern was 5, 2, -1, -4. So our first term was 5. So when x is 1, the term is 5. Our first term is 5. Our second term is 2. Our third term is -1. And our fourth term is -4. So you could try to find the constant rate of change here. So our change in our y values is going to be -3. That's that common difference. The change in the x values is +1. So our slope here is -3/1, or just -3. Now we need our y-intercept. It's the value of y when x is 0. So I'm going to have to work backwards here. If it's minus 3 all the way down, to go backwards, I'm going to add 3. So that's going to get us 8. So b equals 8. And our equation would be y equals negative 3x plus 8. And in the problem, it asked us to find the 22nd term. So if this is our first term, second term, third term, and so on, well, then I'm just going to plug in 22 for x here. So I'm going to have y equals negative 3 times 22 plus 8. And then we're going to have y equals negative 66 plus 8. Y equals negative 58. So we get the same exact answer there. So an arithmetic sequence is just a linear function. Sometimes using the formula will save you some time. If you ever get stuck, just turn it into a linear function and then you could find the answer there. All right, let's go over geometric sequences. So geometric sequences is different from this one because this is addition or subtraction. This one is specifically multiplying. If you see a division pattern, you could just multiply by the reciprocal and then you turn it into a multiplication pattern. So this is a sequence where each term changes by multiplying, has to be multiplication, a constant value called, and we can't call it a common difference because this one is addition or subtraction, so this is called a common ratio, and it's represented by the variable r. So let's look at our example. 1, 4, 16, 64, that's easy. It's multiplying by 4, so r equals 4. Now the variables in this formula, again, you get this formula on the park. The variables in this formula are exactly the same meaning in the other formula with the exception of r. So a is a term, any term. N is a term number. A sub 1 is the first term. And r is that common ratio. Okay? So here's our example here. Find the 6th term. So 6 is going to be our n. And we have negative 27, 9, and negative 3. So I'm going to rewrite this over because we're going to need a little bit of space here. So we have negative 27, 9, and negative 3. And if it's negative, positive, negative, that means that common ratio that we have has to also be a negative number. So since it looks like it is dividing, it's really multiplying by the reciprocal. So it's not dividing by 3, it's actually multiplying by 1/3. So we're going to have here our common ratio be negative 1/3. All right, so when we plug into the formula here, our formula is a sub n equals a to the first times r raised to the n minus 1 power. So n is the 6th term, so we're going to have a sub 6 equals the first term, which in our sequence is negative 27, times negative 1/3 raised to the 6 minus 1. Let's simplify this first. We're going to have a sub 6 equals negative 27 times negative 1/3 to the 5th. And remember your exponent rules. When you're raising a fraction to a power, it goes to the numerator and the denominator. So technically, this would be negative 27 times 1 to the 5th over 3 to the 5th. Oops, and it's negative. And here, since I have a negative times a negative, I'm just going to cancel those out because a negative and a negative is positive. So I'm not even going to worry about the signs. So we're going to have a sub 6 equals negative 20, oops, nope, not negative, 27, positive 27. And then you want to simplify 1 to the 5th over 3 to the 5th. So 3 to the 5th is 243. So you're going to have 27 times 1 over 243. Remember, multiplying fractions, you multiply straight across. So that's a sub 6 equals 27 over 243, and you just want to simplify this. So 27 over 243, you should get 1/9. 1/9 is our final answer. When we go into 9-2 on Monday, we're going to learn about exponential functions, and it's going to be an equation y equals a times b to the x power, where a is your y-intercept and b is your growth factor, which is actually r. It's going to be a common ratio, so you could also call this a common ratio. And this formula is exactly like a geometric sequence where you could plug in the common ratio, the y-intercept, and x is going to be the term you want to find, and you're going to get the exact same answer. Okay, so for example, let's make a table as if we were going to use a table for exponential functions. Our first term is -27, our second term is 9, and our third term is -3. All the way down this table, this is times -1/3, the same common ratio. If I want to find a y-intercept here, I'm going to work backwards. And instead of multiplying by 1/3, you could actually go the opposite, or think about if this is dividing by 3, you can multiply by 3 to get your y-intercept, do that inverse operation. So you're going to get an 81. And if you plug in these values here, so you're going to plug in the y-intercept here, that common ratio here, and this is going to be the term number that we want to find. In our example, it was the 6th term. So let's see. So we have y equals 81, that's our y-intercept, times -1/3 to the 6th power. Okay? Same thing here. We're going to have y equals 81 over 1 times 1 to the 6th over 3 to the 6th. Remember, they're negative. One of them is negative. Okay? Well, if I take -1 and I multiply it to the 6th power, it's actually going to be +1. So I'm going to get a positive answer here. So I'm going to get y equals 81 over 1 times 1 over, and 3 to the 6th is 729. So then you're going to have y equals 81 over 729, which that is going to reduce to 1/9. So on Monday, we're going to learn more about this formula, and you could use this, or you could use a geometric sequence to find your answers. So the next worksheet you guys should have is practice B for arithmetic sequences and practice B for geometric sequences. There is 12 problems on 3-6 and 11 problems on 1-9. So work together on this one. It should be very easy. And on Monday, we'll go over this and the homework from yesterday. Okay, and if you guys want to make it easier, why don't you just do the evens on both of them? This way you don't have that much work to do. So do evens on 9-1, do evens on 3-6. We'll go over it on Monday in addition to nonlinear systems and cubic functions from yesterday. All right, have a good weekend, guys.